Good morning to everyone. Dear students, in the last class we learnt about the octahedral complexes on the basis of VBT, valence band theory. In that VBT we know the magnetic properties and number of unpaired electrons. Okay. If unpaired electrons is absent, that should be diamagnetic. If unpaired electrons are present, that should be paramagnetic. Here they are saying octahedral complexes with coordination number 6. In that we have to know about that the hybridization is d2sp3 or sp3 d2. In that d2 means the d orbital should be present in the inner shell, here this, and sp3 d2, here d2 is present in the outer shell, it means outer last shell. Okay, in that yesterday we learnt about the two complexes, that is one is FeCN6. Here Cn is the strong ligand. First we have to know the d2sp3 hybridization, and in that we have to know about the electronic configuration of central metal ion and its oxidation number. This is the electronic configuration in the excited state. Okay, and we have to write in the box type electronic configuration for outermost, and lastly we have to know the how many ligands are present in that, and how many ligands are present, that much of vacant d orbitals are present with central metal atom. Here 6 ligands are there, so iron should available for 6 vacant orbital to bond with the 6 ligands. Okay, here there is no unpaired electron because for strong ligand the pair up will be started. Okay, and the magnetic property is diamagnetic because there is no unpaired electron, and it is low spin complexes. This is the structure of complex. And next, second one is hexacyanoferrite 3 ion. This is the Fe3 plus ion. Okay, and it has unpaired electron, so it is paramagnetic, and this is the structure. Okay, next we move on to the third one. The next complex is hexacyanocobaltate 3 ion. Here the central metal atom is cobalt. In the last two examples the central metal atom is iron, and in that we have to know about the electronic configuration of cobalt. The atomic number is 27. Then electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d7 and 4s2. Okay, this is the electronic configuration of cobalt. Okay, then we have to know about the oxidation number of cobalt in that. Okay, you have to write the complex COCN6 is equal to how many charges are there? -3. You have to write it -3. Then we have to calculate the electronic configuration of cobalt, that is you have to write as X, plus cyanide has the -1. How many atoms are there? 6 atoms, so 6 is equal to -3. Then X -6 is equal to -3. This will be shifted to here. Then we get X is equal to -3 plus 6 is equal to +3. Okay, the oxidation state of cobalt is +3. Then it donates a 3 electron, it means it loses the 3 electron from the outermost shell. Okay, then for electronic configuration of cobalt 3 plus ion is equal to 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s0, because loss of 3 electron. Here s as a 2 and plus 1 from the d orbital, we get 3d6. Okay, then you have to write the electronic configuration 3d 6. It means d has the 5 suborbitals. You know that dxy, dxz, dyz, dx square minus y square, dz square. This is the 3d. You have to write 1, 2, 3, 4, 5. After that the electron should be remain, then pair up. Okay, here 5 electrons are filled, remaining is 1, then the first electron is filled up, and we have to write a 4s and p orbital also. 1, 2, 3, 4 p. In the last class I was explained you Cn is a strong ligand, then these electrons are pairing up, then 1, 2, 3, 4, 5. First one is already paired up, and then this will be pairing up 1, 2, and this will be okay. The remaining empty orbital is 2, and 1 is 4s. 2 plus 1 3. In that how many ligands are there? 6 ligands. So cobalt have a 6 vacant orbitals. Here 3 vacant orbitals are there, and in that we are writing other 3 vacant orbitals. So that's why we are taking 4p orbitals also. And how many vacant orbitals are there? 6 vacant orbitals, because it has a 6 ligands. Okay, how many d orbitals are vacant? 2. Then d2. How many s? 1s. How many p orbitals? 3 orbitals. d2 sp3 hybridization. Okay, and next we move on to the magnetic property. Is equal to, here there is no unpaired electron, so it is diamagnetic. There is no unpaired electron because it is diamagnetic, and it is low spin complexes. And it is low spin complexes. The structure is cobalt, Cn, 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 Cn. Okay, the charge is how much? Minus 3. Okay, this is about the hexacyanocobaltate 3 ion. Okay, we have to take a cobalt electronic configuration, and then oxidation number +3, it loses the 3 electrons, and we have to write the electronic configuration. Here pairing up because cyanide is a strong ligand, and it is diamagnetic because unpaired electron is absent, and low spin complexes. Okay, this is about the third example, and next we move on to the fourth example. Next, fourth one is hexa aqua. Aqua means water, chromium 3 ion. Okay, here 6 ligands are there, and chromium is the central metal atom. Then we have to know the electronic configuration of chromium, Cr, and atomic number is 24. Then electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 5, 4s2. Okay, in this chromium, sorry, here not a 4s2, there will be only 4s1. Okay, in this chromium they have 3d4, 4s2 is there, but the d orbital should be accommodate the electron from s orbital to get a off-filled electronic configuration. Okay, so that's why it carries a d5 and 4s1. And then we have to calculate the central metal ion, oxidation number of central metal ion. Here you have to write the complex is equal to +3 and you have to calculate X as it as then 0. The oxidation number of water is 0 into 6 is equal to +3. X is equal to +3. The oxidation number of chromium is +3. Then you have to write the electronic configuration for that. Chromium is equal to 1s2, 2s2, 2p6, 3s2, 3p6 and 3d how much? Here 2 plus 1 3, 3d 3, okay, and 4s 0, 3d 3 and 4s 0. Then you have to write the electronic box type electronic configuration and here d orbital. How many suborbitals are there? 5. 2, 3, 4, 5. This is 3d. Next 4s. Next 4p. Here why we are writing a 4p orbitals? Because the central metal atom should form the 6 vacant d orbitals for formation of 6 coordinate bond with the water. Here water is the ligand. Then we have to fill it. How many electrons are there? There are 3 electrons. 1, 2, 3. Okay, here the 3 unpaired electrons should be filled. There is no pairing electrons, and in that also here there is no pair up will be formed because water is a neutral ligand. Okay, then here how many vacant orbitals are there? 2. Then d is 2, s is 1. How many p? 3p, sp 3. Then d2 sp3 hybridization, and here the unpaired electrons are present, then it is paramagnetic and high spin complexes. Okay, then the structure is chromium, H2O, 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 H2O. How many charges are there? +3. This is the last example for D2sp3 hybridization. Hexa aqua chromium 3 ion. We have to know about the electronic configuration and oxidation number, and it has an unpaired electron. In this there will be no pairing up because aqua, it means water, is a weak ligand and also a neutral. It does not have a charge, so that's why pairing up is not formed. Hence it has a unpaired electron. If unpaired electron is present, it is a paramagnetic and a high spin complexes, and this is the structure. These are all the octahedral structure as there. Okay, next we move on to the sp3d2 hybridization. In the last examples we learned about the D2sp3. It means inner shell. Here we have to know about the outer orbital complexes. The coordination number is also 6. Okay, in this type the ion undergoes sp3d2 hybridization. Okay, it means the D will be outermost, present in the outermost shell. Here the ligands is weaker and it is not forcefully pairing up. So the d orbitals are present at outermost shell. Okay, why d is present in outermost? It means the ligands is weaker and here there is no get paired up. Okay, so that's why that should be present in the outermost shell. So that complexes is called it as a outer orbital complexes. Next example is first one, CO F6 3 minus. It means hexa fluoro cobaltate 3. Okay, here the procedure is same, but in the electronic configuration the pairing up is does not exist. Okay, the electronic configuration Z is equal to 27 for cobalt. Here the central metal atom is cobalt, the atomic number is 27. Then electronic configuration is 1s2 2s2 2p6 3s2 3p6 3d7 4s2. okay, this is the electronic configuration. Then we have to calculate the oxidation number of cobalt. Then you have to write the complex COF6 is equal to, the charge is -3. okay, we have to calculate the cobalt X plus fluorine as the oxidation number -1 into 6 is equal to -3. X minus 6 is equal to -3. Here 6 is shifted to here. Then X is equal to -3 plus 6 is equal to +3. Then it gets the charge +3. Then it lost the 3 electrons from the outermost shell, 2 from S, 1 from D. Then the electronic configuration of cobalt 3 plus is 1s2 2s2 2p6 3s2 3p6 3d6 4s0. okay, then here in the 3d electrons it does not form the d orbitals. okay, in that we have to take a 4d. okay, it means in the d orbital you have to see here there is no vacant orbital should be present. 1 2 3 4 5. okay, this is 3d. Next 4s. Then we have to write a 4p also. In the last example we are writing 4p here, and here we are also writing 4d also, because I will tell you later. 1 2 3 4 5 4d. okay, next here you have to write a d orbital. 1 2 3 4 5. okay, remaining is 1. Then it should be pairing up. In the last examples, in the d orbitals there will be pairing up is obtained, but in this sp3d2 hybridization there is no pairing up, because fluorine has the weak ligand and it does not form a pairing up, and so that's why we are writing 4d also. So the d will be formed in the outer shell. okay, then how many ligands are there here? 6 ligands. Then how many vacant orbitals you need? 6 vacant orbitals. Then you have to see here 1 2 3 4 5 6 up to here we need it. And the hybridization is, yes, 1s is there, 3p is there, sp3 and 2d is there, then sp3d2 hybridization. Okay, next, magnetic properties. Magnetic properties, it means it has an unpaired electron, and then it is paramagnetic, and it is paramagnetic and high spin complexes, and it is paramagnetic and high spin complexes, and the structure is cobalt F. How much charge is there? -3. This is all about the hexafluorocobaltate. This is outer orbital complexes, because D should be present in the outer shell. We have to know the electronic configuration and the oxidation number, and you have to write this. And in the last examples, here there will be pairing up taking place, but in this examples there is no pairing up is taking place, so that's why we are taking outer d orbitals, and it has an unpaired electron, so it is paramagnetic and high spin complexes. And this is the example structure of hexafluorocobaltate 3 ion. Okay, last example is hexaquaferrate 2 ions. Here the central metal atom is iron. You have to write iron is equal to 26, 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. Okay, in that you have to calculate the oxidation number. Fe H2O6 is equal to +2. Here you have to write X as it is, and this is 0 is equal to +2. Then oxidation number is +2. Okay, then you have to write iron Fe2 plus is equal to 1s2, 2s2, 2p6, 3s2, 3p6, 3d6 and 4s0. Okay, and in that you have to write electronic configuration 1, 2, 3, 4, 5. This is 3d. Next is 4s. Next is 4p. Next 4d. Here why we are taking 4d? Because there is no pairing up is takes place. How many electrons are present? 6. 1, 2, 3, 4, 5 and 6. Okay, and here there is no taking a pairing up. How many ligands are there? 6 ligands. How many vacant orbitals we need? 6 vacant orbital. Then 4s1, 4p3 plus 2 is equal to 6. Next hybridization is sp3d2. Here we are getting D in the outer shell. Okay, this is all about the electronic configuration, and it is paramagnetic because unpaired electrons is present, and high spin complexes. Okay, and the structure is iron H2O, 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 H2O. 6 H2O is there, and the charge is +2. This is the structure of hexafluorocobaltate. aqua ferrate 2 ion. Okay, this is all about the outer shell orbital complexes. Here the coordination number is how much? 6. The coordination number is 6. Okay, there will be two types, D2sp3 and sp3d2, inner shell and the outer shell. In the inner shell they have 4 examples, in the outer shell there are 2 examples. Okay, did you get it? And next class we will learn about the coordination number 4. Okay, thank you one and all.